Well, we just left Mark's house and we are heading over to, I think we're heading to the ramp. We're going to be showing you guys what's going on there, the latest and greatest.
We're going in the back way.
We're going in the back way, says Mark.
We'll tour these buildings shortly. This is Wilson. This is our plastics thermoforming line. This is building C. This is our machine shop. And then as we go around, you'll see building A, building B, which is the main ramp facility, and the sort of full ramp site that is going to be developed over the course of the next couple of years.
Wow. Mark, be honest, did you pick this site because it's so close to your house?
No. So I actually had my eye on this site in like 2012. We wanted these guys to, or 2010, we wanted these guys to build our frames, and then we were going to use one of these outbuildings for the assembly. We started site selection in November of 2020 for the mass production site. This came on the market 3 days after we started site selection.
Wow.
It was just, the timing was unreal.
Karma. Jesse, I can see why you never let me drive it, because you were just having too much fun. Oh, we need a warehouse too, Jesse. This is so cool. I've been in the passenger seat because Jesse always took the helm. Now I know why he did that.
Yeah, you guys had a wild ride through New York, if I recall correctly.
Yeah, and Austin. You guys were nice enough to let us take one in Austin. We had a great time. But yeah, he would just always jump in the driver's seat, and now I see why.
We'll give him something to be jealous about. We're gonna have a good ride this afternoon. So we're just waiting on Terry and Tim. All right, here they are.
Awesome. Hey Terry, I'm Zach. Nice to meet you.
Terry's our
Tim.
Chief Operating Officer. Tim's our Director of Manufacturing. These guys are gonna walk us through the ramp and show us what this whole thing's all about.
Awesome.
Thanks for your time, guys.
Yep. Oh, wow.
All right. Whoa.
This is our main building right now in the ramp for all of our assembly. But the line basically starts on this side that runs in a horseshoe direction. So we'll start down here.
Great. Now, last update I saw from you maybe a couple weeks ago, you were at like 6 units a week. Is that roughly where you're at now?
We were at building at 6 a day.
6 a day. I'm sorry, 6 a day.
Terry, where do we stand in this moment?
Per shift, we're set up to run 6 vehicles per shift. The production schedule is set up to do that. And barring any part shortages or that type of thing, we're running 6 vehicles per day off the end of the line.
Nice. We had a lot of questions from viewers about supply chain issues. I'm sure they're affecting you guys as well. Has it been really tough, or is it getting better?
It's been really tough. We're doing a lot of things to improve it, bringing some things in-house that have been supply chain issues. And we'll show you what we're doing with our vacuum forming, which literally will solve some very large problems.
Cool. Does it ever get old?
It doesn't. I just always think of this scene from Wayne's World, where Wayne opens the door to a bunch of like training ninjas. I kind of feel that way every time I walk into this facility. It's like, wow, we actually get to do this?
Yeah, right?
It's pretty cool.
It is really cool.
So you can see how the different stages the front clip goes through. You get the drivetrain put on, a lot of the suspension components, and then we put the electrical bulkhead and those sorts of parts at the end here.
Questions from viewers came in about Sandy Monroe and what his team was able to do to help you guys. I know he was helpful, I'm sure, but like any little tidbits you can let us know that he was helpful with? Or
I would say, big things were simplification. Some of the changes that we're doing for 1.x to the front clip came directly out of their work. And then they've been helping us continually with the mass production planning stage, the automated assembly line, all stuff that will come online over the next couple of years.
Awesome.
So yeah, those guys have been awesome. And just for me, the lean design principles was just a fantastic education. So, it's Sandy and his whole team. Yeah, they've been very helpful.
Did the word lean come from Sandy for the lean mean machine?
Actually, no, the Mean Lean Machine, that name originally came from, it was an homage to GM's Lean Machine.
Oh, okay.
Which was one of the very early leaning three-wheel vehicles. And then, mean is like the proper balance. It's also mean.
It is mean.
And there's various sub-assemblies throughout on each side. And then you'll see that backbone that's sitting there. It's just waiting for a front whip to come over and get mated up. Yep. So by the time it's done at that station, it's a roller. And and then it just continues.
Oh, and then
on
we
down.
roll from there. Gotcha. Oh, that's nice. So that makes it really easy to move them around because once you got the wheels on them, they're self, pushable,
And
right?
when we have our full capacity line, our automated line, these will all be on AGVs, automated guided vehicles, that will be traveling at a continuous pace as people are so.
But this must be nice to keep costs low at this point, right? I assume because you can minimize like that kind of capital infrastructure.
Correct.
We've really tried to take the approach of automating the low-hanging fruit, automating the pain points in the production process, and that's kept us able to really optimize as we go forward, but avoid the big CapEx until we absolutely need it.
We have a new robotic weld cell there.
Oh, cool.
So that's going to do our final weld out of the upper frame. So right now we have a couple individuals in manual fab and they can basically get about 2 a day.
Okay.
That machine will do 12 a day.
Wow.
Incremental steps to mass production.
Yeah. Is it true that mass production is the hardest part? I mean, you've been in this for years and years, right? Is this really as tough as Elon says it is?
I've got my own opinions. I would say every part has been the hardest part.
Okay.
And we've just gotten better and better at tackling big problems. I think one of the real advantages we have versus building a full-size car is it's a much simpler platform. It's a much smaller platform. And so, kind of the sort of the super massive production equipment and facilities that you see in Tesla, a lot of those we won't ever have. I think Tesla has put a lot of emphasis on the manufacturing side, but all of the other aspects of the business, getting vehicles out to customers, servicing vehicles, building out the experience model to get actual closed sales, those are also all very complex parts of the puzzle.
Right.
And you've got to basically build them all up at the same time
Right.
to match the flow that you want to get through. And then the other big piece of it that's been even more of a significant challenge due to COVID, that's saying it very lightly, is the supply chain.
Yeah.
And the fact that any shutdown, whether it's a port or a manufacturing facility or port strikes or road issues or whatever, all of those have impact because any one part missing and you don't have a vehicle going out the door.
And how happy are you with the space that you guys got here? It seems like it's big enough for all like future growth. Are you happy so far?
We anticipate the potential market for Arcimotos to be well in excess of 50,000 a year nationally, let alone globally. But this is ultimately the template that we want to use to copy and paste. And once we really prove it out, have not just the product, but the production model fully replicable, that's when, sort of the big ramp hits.
It's a beautiful facility, by the way. Just, hats off to you guys because, I mean, like the Tesla model, it's all white and bright and easy to see.
You should have seen what we got.
I'm sure it wasn't pretty then, I'm sure. Wow.
So yeah, this whole space, this is to bring together purchasing, engineering, get everybody all in the same collaborative space, and then be able to actually look out over the production floor from up here. So it's really bringing the whole team together in one spot.
So again, this is where our automated assembly line will eventually land here. So the beauty of this is we won't have to unplug our space where we'll be manufacturing to build out this space, which will do the next model.
So these are CNC machines?
Correct.
Okay, so you're actually making parts right here. For those of you who are like, what is this machine? Can you guys explain what it does inside?
Well, Jesse named them Very Light and Skinny G. But that's our live tool lathe that does a lot of all of our turn parts. Okay. So any of our bushings, any of our suspension components all get made on that machine.
Oh, wow.
The horizontal mill does all of our different steering components, steering knuckles, all those different parts, and I can show you examples of those.
So let me just ask you a dumb question. Why not just buy the parts? Why make them? Why is it better to make them here? Is it cheaper? Is it quicker?
If you think about the turn time between getting an external shop to quote a part, mill a part, get it back, when we can do it with our own team in a matter of days, it makes development go much faster. So these machines are designed for production, but also we squeeze in prototyping pieces along the way.
And so you got a bunch of machines now, but you just said you're getting a bunch more?
So we're getting a new system that's going to basically go up against that wall.
Okay.
It's called a linear pallet pool, and it will allow us to run lights out. And that machine will be able to run 24/7.
Really? What's that machine going to be named? Do we know yet?
We don't know yet.
Think of a name, guys.
Huckleberry.
It doesn't sound
I don't know, but
sexy
it's
enough.
like,
it's running
It's Tim's
24/7.
Huckleberry.
Dude, I know you see this every day, but this is really freaking exciting.
And every day it changes,
Yeah.
practically.
Yeah.
I mean, the site is under continuous development.
Yeah.
New machines come in, new processes in place. It's really freaking cool.
Wow.
So this area, vacuum forming area for all of our ABS body panels, this system that you'll see is the first one in the U.S.
Really? Why is that? Like, why isn't this more popular here in the U.S.?
From this company. Yeah, from this brand of
Oh, from this
equipment,
brand. Okay,
and
gotcha.
This the way it's set up.
Gotcha.
It's the first
Okay,
one.
gotcha.
But it is really, literally one of the most advanced vacuum forming machine setups in the world.
Yeah. This machine here is the actual vacuum forming portion.
Okay.
So you'll see these molds. They're
Oh,
aluminum
Jesse, are you
cast
drilling
molds.
right now?
And the molds go in the bottom of the machine.
Mm-hmm.
And then it has an auto sheet loader on the left-hand side. So it grabs the ABS sheet, brings it over, sets it in place, and then there's halogen heat lamps that heat the material. And then the mold comes up, vacuum forms it, shoots it off, robot grabs it. So once it's complete, the robot loads it on this conveyor, it comes out for the next process, whether it's sonic welding, gluing.
So another dumb question: if you guys iterate and you need something to change a little bit, can you do that here? Like,
That is a very good question, and something that's
And we can cut our own tooling. It's one of those machines that can make its own parts.
wow.
And it's like the CNC machines making CNC machines.
Wow.
This can make the tooling that we use for prototypes.
so. What you see on the shelf there, that's the hard tooling.
Correct.
That's for making many parts.
Right.
What you see on the shelves here, that's sort of the soft prototype tooling that this machine can make.
Oh, so if you don't need that many parts and you're just trying something out.
Yeah, or if we're iterating, again, it's that speed of iteration. So it's the super cool thing about really all that we've set up from laser cutting to welding to machining to plastics is that it is great production equipment. It's also really great prototyping equipment to speed up the development process on all the different programs we've got
That's
going.
so cool. And has that led to some of the reasons why you guys have come up with so many new products recently? That you were able to do it?
Well, it's and actually a lot of that work's just done in our R&D shop. But when those products go from an R&D concept into, okay, this is going to be a production product, that's when we do the work here to get the plastics right, program in the lasers and the benders and so on to get the metal fab right. But yeah, it really, and the real key differentiator of Arcimoto from anything else we've seen is just the true flexibility of the platform for the whole range of, kind of everyday last mile, last 10 mile, first 10 mile type trips. And so this manufacturing setup really lets us leverage that.
So you asked earlier, why wouldn't we just have this made in China or even down the street? First, they'd have to have a plant that's as capable as this just to keep us.
Right.
But almost more importantly, is if you look at this stack of the shipping of full body panels and kits would be the shipping of a lot of air. I mean, we'd have containers full of air. Whereas when we buy our raw material, this
it's
is the
just
whole
packed.
stack of raw material. It doesn't get any more dense
Right,
than that.
right.
And that's what we utilize to make the parts. And the parts just go about 100 yards to where they get
Right.
actually assembled.
And so you can pretty much make them as you need them. You don't have to store warehouses full of parts if you
Right.
don't need to. Okay, that's so smart.
I mean, there will, for some of the plastics, there will likely come a time when it makes sense to injection mold certain parts if we're building, 50, 100,000 vehicles a
Right.
year. But there you're talking about incredibly expensive tooling.
Right.
And that's where you really want to make sure everything is perfectly dialed for
Right.
mass production. And that's where we'll get there in the next couple of years and then start pulling pieces that we are currently making this way and shipping them off to much higher volume suppliers. But yeah, think about just this part starting as a flat sheet and then with no human intervention popping off as a finished part,
Yeah.
trimmed out. So even when you think about the, a potential, what people call low cost countries, what we're really trying to do is blend the right amount of automation with good paying jobs.
Right. I think you have a really good point. I mean, yeah, maybe you can make this for pennies cheaper somewhere, but then you have to factor in so many other things that no one ever factors in. I mean, you're factoring the fact that you have it right now, so you're not going to wait 9 months for it or whatever. It's exactly what you guys asked for. And like you're saying, if you need to make a change, you don't have like 9,000 of these that you don't need anymore.
Yeah, not to mention if you've got a port shutdown because of COVID
Yep.
on the shipping side,
Yep.
then you've got it weeks on the water,
Yep.
and then you've got a port shutdown because
other
of
side.
congestion or worker strikes or whatever. There's a huge amount of de-risk that comes
Yeah.
from localizing
And without
production.
this part, you can't move on.
Right.
That's so smart.
All right, well let's head over to the amp.
All right.
Check out the original Arcimoto
Where it all
manufacturing
started.
plant. Yes.
So yeah, the original assembly line ran right through here,
Yep.
and then we fed it just like we do at the ramp from each side. All of this equipment was the first capital equipment that we invested in.
Okay. And what is it? What's it doing?
So this machine is a sheet/tube laser.
Okay.
So it cuts all of our upper frame tubing, seat back tubes, all of our tubes that go to the vehicle. That portion of it cuts all the sheet components, which I'll show you.
Okay.
And then from there it goes into the tube bender and then goes into the welding robots. So I'll show you some of the process.
Lead the way.
So basically we can take a bundle of tube,
Okay.
pull it up, load it into this side, and it auto feeds into the machine.
Oh, okay. Cuts it and okay.
It
Gotcha.
processes it, does the different things. This side, you can see the laser cutting through here. So this is full sheets of sheet metal that come in, and there's 2 tables, so it shuttles in and out.
Okay.
He's getting ready to set this up and run. And then, so we can go from sheet cutting to tube cutting.
Awesome. And so can you actually look in here when the laser is doing
Yeah.
its thing?
Oh yeah.
Wow. And that's thick. How thick is that? That's like 1/8 inch, eighth inch?
That looks like 11 gauge.
Okay.
Yeah, so pretty close to 1/8 inch.
Wow.
So right now it's putting the sheet, finding the orientation of the sheet. So it does what we call edge detection. Now it's cutting.
Wow, that's it right there. I would want my office right here just so I could watch this all the time.
And with us investing in the new lasers, with the cut speeds that they will have, this machine will basically turn into only cutting really thin sheet metal
I see.
and processing all of our tubes,
Gotcha.
which allows us not have to spend a massive amount of money on just the tube laser in itself.
Smart.
So if we go
it
to
fulfills some primal thing in me, like
Lasers.
lasers, metal.
The other cool thing actually that's come online very recently are the automated feeders for the press brake. And again, this speaks to the approach of automating the low-hanging fruit. So we started with a CNC press brake that's all computer controlled but manually operated, and then we're moving into an automatic feeder for that. So basically a robot arm that aligns the piece and puts it in the machine.
And a brake is a machine that bends metal.
Yeah, it's
correct.
You can kind of think of it like it's basically
okay.
it's sheet metal origami.
So this
Wow.
basically comes out in flat sheet like he's organizing there, and
And
then
then
it
gets
goes
folded.
to its next process.
Wow.
So this machine will run lights out. So you just stack up as many parts as you need, and it just bends all night long
Wow.
or all day without any attempt.
Right.
So you'll see this gentleman, he's pulling all the already cut
Oh,
parts.
this is the back side of the machine we were just looking at? Is that
Yes.
okay?
So right now it's processing another sheet, and now he's pulling these parts for the next operation.
Cool.
Now with the new laser, we won't need anybody to do this.
Oh, it'll just be
It sorts it all on its own.
wow.
So these are all the different Kanban systems we have that all the different parts go into before they go to their next process.
Okay.
So some of them will go straight to the weld cells, some of it will go to a press brake and get the next process.
That's
So
so cool.
if you think about this in the context of like large scale automotive, these would be stampings. Like so you go into the Tesla factory, you see a bunch of giant press, the 50-ton press,
Ka-chunk.
ka-chunk. The advantage of doing it this way, particularly as we're approaching, is like it's the catalyst to get to volume production. Again, it lets us iterate much faster. Anything that you stamp, you're talking about incredibly expensive, very long lead time tooling.
Right.
So,
and you can't change it.
and once, changing it is practically, it's a very complex,
Right.
costly process to change. Whereas we can iterate very quickly on, it's to get a different pattern is a new program, a new program for the outline,
Yep.
and then a program for the press brake, and then put it on the welding robots, and you've got a new
I didn't
part.
realize that. I thought you just go from prototype to mass production, but what you're saying is there's this ramp and you have to be very careful that you don't go too fast or too slow.
Well, you've got to have. To me, it really lets us dial in the product based on market feedback, really identify all the different variations that we want, and dial those in, and then again, once we're at 50, 100,000
Once you
plus
know you
units,
got it, right.
and it's like that part is not going to change ever.
Right.
Then you
Go
tool
for
it up for incredibly high volume production, and that frees up more time on our lasers
Yep.
and benders for other parts.
That's so smart.
So as you can see, we cut the tube side cuts the profiles,
Oh, wow.
so it copes all of our tube.
Yeah. So not just simple cuts, these are complicated cuts.
Correct.
Yeah.
So generally, somebody does that by hand or in a mill, where the laser head does it for us.
Wow.
So before it gets bent, this is basically that tube before it gets bent.
Oh, wow.
And you can see that profile cut in here and that hole. So what we do is we micro joint it so it's still there, but we have the cope. That hole, when it goes into the tube bender, it spins it, a laser finds that hole, puts the tube in the right orientation for that cope and that
to
cope.
line up.
And then it bends it, and then this snaps off.
Oh, that's cool. That's really cool.
So once it comes off, as small as this shop was, it forced us to be as lean as we possibly could because we don't have a lot of space.
Right.
So we custom designed this robot cell the way it is because of the floor space.
Okay.
So basically, the upper frame and seat back parts get processed here, get racked up, go to the tube bender, and then go straight to here to this
Just
fixture.
loop back around.
And then
Oh, so this fixture is doing something, like it's making the...
this fixture, after the tubes are bent, welds the sides of the upper frame.
Oh, okay.
And then once that's done, ultimately, eventually it'll go to that cell that I showed you at the ramp.
Gotcha.
But right now we made it up manually.
And this would have been subbed out to some other company.
Correct.
Wow. This all in-house. That's great. Jesse and I just learned to weld this year, and so I'm a little jealous because the speed with which you guys can do things is amazing.
After all this, we end up with some amount of tube and sheet metal origami, and then what happens next?
So this is component weld cells. These two cells are identical.
Okay.
So we do all of our suspension components, our seat bases on this cell. It's a Ferris wheel system, so it flips in and out. And then this cell does our backbone chassis and our front clip.
And so this is laser welding? Or
This is MIG welding.
MIG welding. Okay, cool. Wow.
And at the end, you can see what comes off, right?
Look
So
at this. We got all these pieces put together into an amazing looking part.
And it's just these welds come out like toothpaste.
Yeah, look at that. And now I know what I'm talking
I
about.
know
And those
how
are gorgeous
I know you
welds.
and Jesse weld just like this. at
Just
this
like
point.
that, yeah.
So-
Just dimes.
We've got a spot for you in the fab shop.
Perfect.
All this fab is going to move over to the ramp.
Right,
This
okay.
will become our automated battery production line.
Oh, okay.
And then this is the line that we have now for battery production.
Interesting. So this means that you guys are actually making your packs here?
Yes.
Wow.
Yeah, so we take, and these are, it's an awesome pouch cell that we get from Ferrisis, but we basically sort, pack, do all of the crimping, and then fill the tub with potting.
And that's going to expand into this building.
We're going to basically put a larger automated battery production facility on the other side of this
Gotcha.
wall to be able to get up to high volume.
And can you share with us what the is this LFP? Is this
So we're, we talked about this a little bit at Ramp It Up, which is a new battery pack architecture based on 2170s.
Okay.
So that'll allow us to build both with pouches and with cylindrical cells.
Oh, cool.
It's a major de-risk on the supply chain side, and then also lets us build a battery pack for the mean lean machine.
Nice.
So our battery 2 technology is actually, it's a very scalable battery architecture. We haven't released any real details on that. That will be coming soon.
Cool.
But it's one battery pack architecture that can scale all the way from the mean lean machine pack all the way up to a FUV pack, and then ultimately to much larger vehicles.
Smart.
I want to introduce Brad Harness. He's our director of R&D, and
Hey, Brad. Hi, how are you? Good to meet you. I'm Zach.
and Brad and team have been. So you've heard about the torque vectoring software
Yes,
work we're
I
doing,
did.
which is going to make steering effort a lot easier. It's also going to make for better traction, better acceleration. What the team has also been working on, and we talked about this a few weeks ago on the stakeholder update, suspension and steering changes for 1.x. What these guys have been doing is reevaluating some of our steering process on the existing 1.0 hardware.
Okay.
And so you just had a chance to drive mine around a
Yep.
bit. We're about to go up for a longer ride.
Yep.
But I want you to try this one before we go.
So is this kind of like Skunk Works here? Like
This is, yeah, so this is Brad and his team do all of the different vehicle variants
Okay.
before they get greenlit for production.
Before I hop in, can you just explain what is torque vectoring for the crowd?
Yeah, so one of the, and this is, torque vectoring has been the plan ever since we started Generation 8 in 2015.
Okay.
And that's what, one of the reasons why we have two motors, one for each of the front wheels. So
Okay.
each wheel is independently controllable. There's no hardware differential. The differential's a software function.
Okay.
And that software that sort of shipped with the controllers that we use is pretty primitive. So we've been working with Stoffel Systems to have a much more refined software controls of that software differential that let us do really precise measurement of traction, and then also measuring sort of how much steering effort you're putting in, and actually spinning the outside wheel of the turn with more torque than the inside wheel, so it actually helps you through the turn.
Wow.
That's not what you're about to experience. What you're
No.
about to experience is what Brad's been calling R&D vectoring, which
Okay.
is
What's that?
it's a hardware improvement
Okay.
in the steering linkages
Okay.
to make steering easier. And so when you layer in all of those pieces, the hardware changes, the torque vectoring improvements, that's what also is going to be really foundational to our autonomy platform.
Okay.
Because we've always envisioned the platform itself as being an ideal solution for various different driverless tasks.
Okay.
Whether you're talking about delivery, and we're going to talk about that actually on this week's update, what the team at Faction has been doing on the autonomy and driverless side.
Okay, so what am I going to experience here? What's should
Well,
I hop
want
in?
you to just
or?
try
Oh,
it and just steer
All right.
around.
All right.
See if you notice any difference.
Okay. Could we ready to go here?
But
Oh,
you
I
got to
gotta-
put your seatbelts on.
I have to, Mark?
Experimental vehicle.
All right. Are we fired up? Do I need to do anything? We're good?
I think looks like
Okay.
you're good to roll.
All right. Oh, I'm going very low speeds and I already feel something different. It's very easy to turn. I'm going to go up here and turn around a little bit. Oh, wow. So at slow speeds, I can turn really easily. Reverse. It seems a lot easier to turn the wheels, and we're going very slowly right now, like 3 miles an hour, and yet it's, I would say, effortless to turn, and I'm only going like 1 mile an hour.
We've been working on basically the same steering linkage geometry setup since 2015. We've had world-class engineers from Arcimoto, from Monroe and Associates, from a number of different partners looking at, how do we improve the steering feel, and ultimately, it's a function of leverage. So shortening of one of the key members in the steering linkage to give you, you have slightly more of a steering arc on the
Okay.
handlebars, and
And
much
that's just
more
hardware.
leverage.
Okay.
Just
Just hardware.
simple hardware
So what I'm
fix.
feeling right now is just hardware.
Right.
Interesting. Wow. So this isn't even bringing in software. I'm just feeling
Correct.
a hardware change that you guys made, and
Yeah,
that's
so-
already astoundingly different.
And the software is again going to be now layered on top of that.
Interesting.
And the net result is once we get this through the engineering change order process, this is something that we'll be able to offer as an upgrade to existing customers. It's something that will go into our production vehicles sooner than all the 1.x stuff that we talked about weeks ago.
So what's the time frame on this? You still need to kind of test this in the field, and then
Put a lot of miles on it, do a lot of validation on the tube in terms of finite element analysis, and then just run it through the full ECO process, which is all the drawings, changes of parts, changes of assembly method, to go into the production vehicle.
Wow. And then at the same time, I assume kind of in parallel, your software team is working on the torque vectoring software side.
Correct.
Wow. So they're going to work really well together.
Yeah.
That's awesome. Thank you, man, for letting me ride this. This is great. Amazing.
Well, welcome to our...
From one amazing thing to another.
We've been working for a while on a concept called Future Drive,
Okay.
which is the for the full-size FUV, and that's something we'll talk about later on down the road.
Okay.
Micro Future Drive is for micromobility, and the idea is it's a full co-packaging of battery, the inverters, all of the telematics, gyros. It's sort of a one box.
Just in this?
Yeah, so it's going to be a one box quad inverter for micromobility.
Wow.
And the intent is not that we just use it on one product, but actually there's a whole range of micromobility products. When you combine the Micro Future Drive and then the Arcimoto wheels, which is it's a hub motor built into a wheel.
Hang on, just slow down for a second
All right.
there, bucko. You're talking about there's 3 motors, each of them is in the wheel?
Yeah, there's actually 4 motors on this vehicle. The 4th is the one that you pedal. So you're pedaling, there's no chain, there's no belt, there's no grease on your leg. You're actually pedaling a motor which is a generator.
Okay.
And then it's giving you, and that's actually not working at the moment.
Okay.
We've had upgraded inverters and stuff.
You slackers.
Yes, you're catching us in the middle of getting all of this working.
Okay.
So for your ride, you'll have a thumb throttle.
Okay, right there. Okay.
But and you can see it on the videos online, when that thing is going, it's coded right now to feel like a bike chain.
Really?
Yeah, so it feels like you're pedaling a bike, but you're pedaling a generator controlled by software, which also means that when it's stationary, you can charge it up by pedaling stationary.
No way.
So it's like you're, it's like a Peloton that you don't plug into a wall, which is an absurd thing about exercise.
Right. Don't get me started.
Anyway.
No, so what you're saying is if I bring this home, put it in my garage, whatever, I hop on it, I ride it, use my leg muscles, get a workout, put power into the battery.
Correct. Put the helmet on.
Wow, from one amazing experience, I think, to another here.
You'll hear a few things. These are the gear. There's a bit of gear noise on this.
Okay.
The wheels have new gear sets coming that are going to be much quieter.
Okay.
We spent a lot of time working on ergonomics.
Okay.
So that it's sort of a one size fits almost everybody, and you're really only adjusting the seat post.
Okay.
But give that a sit and see how that fits for you.
Ooh.
Reasonable?
Yeah. So you tackle him as he tries to stop me, okay? All right. I get the hang of it. You get the hang of it fast. Oh my God, this is fun.
Really, at the end of the day, the reason for the mean lean machine, you think about GM's electric Hummer, or the.
I don't want to think about it, but yeah.
Like, you're thinking of that as clean mobility. You can build 8 fun utility vehicles, assuming we hit our targets with 1X.
Okay.
That same amount of material.
Wow.
You can build 100 mean lean machines.
Wow.
With the same amount of material.
Wow.
And so when you think, we all read about the supply of raw materials, the amount of extracted, sort of earth punishing ways in which those materials are gathered. The graphs they don't line up if we're building giant cars to solve the mobility problem.
No, and I'll tell you, you'll want to go get a coffee on this. Like
the idea here is to make the e-bike world, make it safer, make it higher carrying capacity. There's lots of stuff. I mean, the accessorization that we're going to do here for delivery, for personal mobility, but just really expand that class to a much wider audience that doesn't want to fall off a bike.
Yeah, I just want to stop you there. Not want to fall off a bike. I'm at that age where, like, riding an e-bike, you can hit some gravelly patches and you can go flying. I almost encountered that in Provincetown earlier this summer.
Yeah.
On this, that wouldn't happen. I can tell right now.
Yeah, and even just thinking about your seating position, you're in a sort of
I'm going to lower to the ground.
position.
Yeah.
You're not up over the handlebars, so
I feel much more in control. I love this feel. This is you guys really nailed it.
you might actually, I think you might be the first one outside the company to actually get it.
Really? Dude.
Thanks for being
Wow,
on.
I showed up on the right day.
Yeah.